Hello, welcome back to another science episode, and today we will discuss the GOLGI apparatus. Okay, but before that, I want to note down how, we recently hit 12,000 subscribers, right? But I think it's now 13. Whoop whoop. But for the 12,000 one, I was like, why not to celebrate? Do 1,200 jumping jacks, but not all at once because that's gonna be crazy. I was like, divide it by 10, like into 10 sets. So sets 1 to 10. So that'll be 1,200. And so far, we've done 1, 2, 3, 4, and 5. And I think that it was we finished 5 sets. Let me just make sure. Where was it? Yeah, 1, 2, 3, 4, 5. And that means how many is that? That's about 600 already. And we're gonna do the 6th right now. Okay. 1 second. I'll move the chair. Jumping time. Okay. Let's go. Whoop whoop. Yes. Whoop jumping jacks time. Hello Greg and hello George. Yeah, the 6th set is happening right now. And I'm not sure if the code works, but so far I'm trying the hype train code. But yeah, it's up there in case it works. Well, that means the code works. Okay, jumping jacks time. Let's go. Wait. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. Is it working? 30, that was 30. Don't forget that was 30. 30. Oh my gosh, okay. 1 second. That was 30. Remember, don't forget that it's 30. 30. Okay. And 31. Whoops, chair. 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Okay. 50. Hello, screaming action. Welcome back. Welcome to the stream. We have done 50 jumping jacks so far. For the next set, 1 moment. We're trying to do 120 for today because of this thing. That post that I made. In other time zones, it might be flipped. It might be +3, -3, +15, -15, +7, -7. The GMT range is a lot. What number was I at? 50? Okay, 50. 50. Let's go. Wait. 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. Wow. Yeah, when I do the debut stream at some point, I'll make sure to clarify details there as well, so that it's not so confusing. 70? Was it 70? I was at 70. 70? I am. It might be similar to Millie Parfait. If you've seen some streams of hers, that's the mini clue I'll give. It's similar to the case of Millie Parfait. Yes. Except I'm not in Niji Sanji. What number? 70? 70, right? 70? Yeah, 70. Okay. 1 second. 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. Is it 80? Am I winning? Almost winning. We're doing the 120 jumping jacks because of the 1200 jumping jack celebration for 12,000 subscribers. That was a while ago. That was 80, 80, 80. Okay. 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. That's a lot. You know, why not for the remaining 20, I'll count on Ya's dedication. I'll count in Chinese, Japanese, or Filipino. Oh my gosh, okay. The remaining 20. Siya in Tagalog or in Bisaya? It's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. Or 1、2、3、4、5、6、7、8、9、10、11、12、13、14、15、16、17、18、19、20. Okay, I think I'll go. Or I'll do 1、2、3、4、5、6、7、8、9、10、11、12. No, I'll go Chinese. Why not? Last 20. Let's go. 1、2、3、4、5、6、7、8、9、10、11、12、13、14、15、16、17、18、19、20. Okay. Let's go. The 6th set is finished. I-on na natin ang aircon. Mainit na. Okay. The aircon is now on. Wow. Hopefully the mic doesn't pick up the IAC. But yes, I'll make sure to include some some of the details, but my biggest clue is it's kind of similar to how Millie Parfait is set up. And I go in between the South and West Elysium if you watch the Holo Stars terminologies. Same as how they refer to different areas of the universe. That's why it's an isekai thing. Here and there, everywhere. But we finished the 6th set. Whoop whoop. So now what are we at? 720. Wow. Crazy. Okay, anyway, let's now start discussing the GOLGI apparatus. Alright. So, what's the GOLGI apparatus? It looks squiggly. That's one of the things about it. But it's mic. Let me just move the mic. And angle. There you go. I think it's tracking my face now. So the GOLGI apparatus, it's a single membrane organelle composed of 3 to 5. Can't see my notes. 1 second. This is lots of floating things. Oh my gosh. Wait a second. Just in case they all fall apart. Okay, it's not. This one works. So the GOLGI apparatus. It is a squiggly. Oh, it's a squiggly thing like that. Nope. That's not how it looks like. We have to make it Picasso level art. It looks like this. Like that, with some squiggles. Like that. Okay? And it has 2 faces. The cis face If the GOLGI is here, that's the GOLGI. GOLGI. It has the cis space and the trans space, and the main difference of that is the cis space is near the ER. It's near the ER, and note that the ER is kind of together with the nucleus. So the trans space is the one outside it. And although the number of cisternae of the GOLGI varies depending on the cell type, it's divided generally into 5 domains. You have the cis, I'll write it in red and lessen the thickness of this one. You have the cis GOLGI network. You have the normal cis, you have the medial, you have the trans, and you have the trans GOLGI network. GOLGI. So that's 5. Again, I will close my eyes so that it gets stuck in my head. You have the GOLGI apparatus. It has like 2 sides, the cis side and the trans side. The cis side would be near it's facing the ER, which is near also the nucleus. And then the trans side is the one away. And in terms of the 5 domains, you have the cis GOLGI, you have the cis, the medial, the trans, and the trans GOLGI. Beautiful. Yes. Is it Ichiban Sensei, if that's the term? Okay, and the ER is also known as vesicular tubular stuff. Alright, okay. The structure of the GOLGI fluctuates with the cell's secretory activity. I think this one will work. Yeah, secretory activity. And for example, you have the mannose 6 phosphate receptors. They are, I have to draw it. The mannose 6, where is it? It's in the trans. So the mannose 6 GOLGI network, phosphate receptors, it's here in the trans GOLGI. So the M6Ps are in the trans GOLGI. And furthermore, the vesicles near the trans GOLGI are much more abundant and bigger compared to the ones near the cis. So mostly found in the eukaryotic cells. Yeah, I think so, but I think both of them would have this, but the more simpler prokaryotic cells. It depends, I think. But yes, this one is more, we're focusing on the protein delivery to the GOLGI apparatus. Oh, and speaking of which, what's the main function of the GOLGI apparatus? It is, let's see, main function. Let's erase this. Here. Main functions. The main functions would be protein modification, and then you have protein sorting, and then you have membrane recycling. There you go. So again, protein modification, protein sorting, membrane recycling. What's the function of the GOLGI apparatus? Protein modification, protein something, membrane recycling. Protein sorting, oh my gosh. They modify and then they sort and then membrane recycle also. Okay. And the proteins are sorted and packaged into vesicles in the trans GOLGI. And depending on the signals, they can go from the GOLGI to the plasma membrane or lysosomes. Note, the carbohydrates of glycoproteins are attached. So let's say you have this is your protein, right? Composed of amino acids. The carbohydrates are attached to it either via N-linked or O-linked oligosaccharides. N-linked would be on asparagine residues. How does that look like? Let's see. You have COOH, you have H, you have NH3 plus. Then you have Oh, what's the middle part? I think it's like the CCCCCN, just to make sure our friend Google will help with the asparagine structure. Okay, one moment. Asparagine is... Oh, is this AS... Where was it? Asparagine residue. Yeah. Oh, it's not that one. This one is just CH2, CC, and H2 double bond O. So it's here, attached to here. The N, the nitrogen. Again, let's write this part properly. The main functions of it. Main function, main, here. Main function of Golgi apparatus would be protein modification, protein sorting, and number 4. Wait, 1, 2, nope. Number 3 is, what was it? Membrane recycling. Oh, I just noticed the question. Thank you for the 13k subs. 13k push-ups, that will be crazy. If it's 1300, then I think I can just add... Okay, if it was 1200, I can just add an 11th set, which will make it 1320. I think that one's fine. That one will work. Haha. But we are just at set 6 out of 11. So, membrane recycling. Finished. Okay, and then after you go through the Golgi, it can be delivered to the plasma membrane depending on the signals, or the lysosomes. And then, what's the next one? Connected via O-linked or N-linked. And asparagine would be... Asparagine is this... Right? ASN? ASN amino acid. Yeah, asparagine, ASN, and also N. This one is COO minus, H3N plus, and then you have... Is this H3N or H2N? Ah, let's just use a normal one here. Let's use a normal one. H2N. And then this is just a hydrogen. CH2 and C. Double bond O. And H2. Beautiful. Beautiful. So that's asparagine. That's where the molecules will go. And why do we need to put the sugar molecules on it? It would help stabilize the proteins, and it would serve as sorting signals. So for example, the mannose 6-phosphate is a sorting signal. It would influence the accessibility of sorting signals and all that. N-linked oligosaccharides, yes, glycosylation. Perfect. Glycosylation would be you put sugar molecules on these. Some of them, because there's a theory that it's not actually in all of them. And why do we want that? It could be, okay, here's the thing. It could have high mannose oligosaccharides, which contain only the NAG, N-acetylglucosamine, and mannose. And it could be like complex oligosaccharides, which has fructose, galactose, and energy acid or sialic acid. And the polarity of the Golgi is reflected in the arrangement of the carbohydrate residues. So it's all like, it depends again on what type it could be. All right. So for, where is it? Synthesis of it. Let's erase this. Erase. The synthesis. This mic, it's blocking my view. Okay, how can I move it such that it doesn't block? Oh my goodness, I realized something. Wait, let me just adjust it really, really quickly. It's gonna block the camera for a bit, just a tad bit. I think this works. If I curve it this way, there you go. Okay, I think that works, right? Okay, this one works. Okay, synthesis of N-acetyl glucosamine. This one, okay. The letters are so tiny. My eyes. N-acetylglucosamine. So it begins in the ER. That's a thing we have to remember. It starts in the ER, and it's the end-linked oligosaccharide is translationally transferred from a lipid carrier to an amino acid residue. So if you have this, you have your membranes, they will be, and you have your glycan here. You have your glycan. And then you have an amino acid that's kind of growing. You have your asparagine residues here. The OST will transfer it to here. Okay. And who is the OST? It's oligosaccharyl transferase. Specifically A, because it's said co-translational. All right. No. Stepwise assembly. Okay. Where's the picture? Okay, there you go. I have a picture now. The picture is here. Why did I make the letters so small? I cannot see it. Wait, I will bring the notes nearer. Here you go. Okay, for the synthesis of it, this one will take a lot of steps. Lots of steps. So, you initiate the dolicol first. Okay. Let's write it here. Dolicol phosphate. You have the P. Go in here. Phosphate. Like that. So initiation of the dolicol linked oligosaccharide. You start in the cytosol where NAG or N-acetylglucosamine, the red squares, are added to the dolicol phosphate. So you have dolicol phosphates, and then you have the red squares, I'll call it NAG, N-acetylglucosamines. And then you add the mannoses. Oh my gosh, it will look like this. I can't draw it there, so that's why it's gonna look like that. The mannoses will be added there. After you add it, they will be flipped. Into the ER lumen. So now they look like this. I'll draw it. Phosphate. And then NAG. And then manos. They flip. Okay? After they flip, you continue glycosylation, aka adding more manos, and you also get more glucose here. You get glucose here, glucose. So that's how you finish your lipid-linked oligosaccharide. And now, the next would be the co-translational transfer of an N-linked oligosaccharide from a dolicol linked. Oh, that's finished. We just have the oligosaccharyl transferase. All right. Note, you have your ribosome. Yeah, you have a ribosome here. You have your growing protein here, growing amino acids here. And then you have your asparagine over here. And then you have the NH3 somewhere around here. NH3 plus. Why is it in this drawing? It's not clear which N it's added to. But alright then. Then your phosphate is gonna be somewhere here. It's gonna be added. There you go. It's gonna be added that way. Oh, no. I'm gonna add it here. See? Now, this is N-linked glycosylation. Again, how is it? Like, what's the steps for N-linked glycosylation? You first start with the dolichol phosphates, phosphate, and then you add your nags, 2 nags, and you add your mannoses. And once that's finished, you flip it into the ER lumen. Then you continue adding the glucose. And then after that, you put it to the growing protein using the oligosaccharide transferase. Okay, perfect. Now, I mentioned earlier there are 2 types of glycosylation. The other one is O-linked. Okay? The other one is O-linked. So the sugars of an O-linked oligosaccharide, they're transferred from the nucleotide sugars to the protein. N-linked, the first residue of an O-linked, NAG, the first residue of an O-linked oligosaccharide is transferred to the hydroxyl group of serine or threonine. So that's the biggest difference between them. The N-linked, erase. The N-linked is, let's see, over here. N-linked is for asparagine, aka like this, COOH, H, and H3. Oh no, let's make it 2. I don't want to do H3N plus. And then this one is CH2. And then this one is no. This one is NH2 and double bond O. But for O-linked, it's gonna be on serine or threonine. I think serine is, it reminds me of the team in Kuroko no Basket. Serine, it would be CHCOO. Let's go minus. H2N plus. H3N plus. Okay. CH2OH. Threonine, I think, is the weird looking one. COO minus. H3N plus. Is this the 4 one? It's threonine. Oh, okay. So it's just CCOH. CCH3. Then you have an H. Yeah, the L version. CC and OH over there. So that's threonine. What's the next one? Yes, mostly in O-linked, it's like glycans. Yes. Now, sorting the meat of the buns of the burger. Golgi apparatus its role in glycoprotein is processing and sorting. And we have a figure that I will try to draw. Yes, it is attached to the oxygen atom over here. I think so. Yeah, oxygen. Now, the next one is how it processes. So in my head, Golgi apparatus it's like Amazon. So it would package stuff and remove stuff and all that. So you have the ER. It's coming from the ER. It's clear, right? Yeah. And then you sort. You go here. There's one. I'll draw 1, 2, 3, 4, and 5. This might be hard to see, but let's go. Yes, it delivers the packages of proteins. Exactly. But I don't know if this will fit here, so I'll just try. The first one is, okay, it's sorting, right? The phosphorylation of oligosaccharides on lysosomal proteins. Oh, speaking of which, locations. This is the cis-GOLGI network, cis-cisternae, medial cisternae, the trans-cisternae, and the trans-GOLGI network. This one's the locations, the 5 areas earlier. So in the cis part, you phosphorylate the oligosaccharides. Phosphorylate. You add the phosphates on lysosomal protein, right? And then on the cis, you remove mannose. Medial, remove mannose and minus mannose and add plus nag. Okay, I think the colors will help. Now, the trans part, you add gal and nana. I'm just shortcutting the terms because their names are long. This part is just sulfication. The last part, I'll just make it blue. This one is sulfication of tyrosines and carbohydrates. Oh, that's a green because that's adding stuff. Sulfication of tyrosines and carbohydrates. And after that, they would just get delivered to the lysosome, plasma membrane, and or the secretory vesicle. Okay, so just as a mini review, let me just picture what I wrote here. There you go. As a mini review, you have the sorting. Okay, no, I'll write it. I'll draw it. This will help if I just draw it out. If we draw it repeatedly 10 times, it's gonna stick, right? Right. Okay. We have the ER and the 5 sections. 1, 2, 3, 4, and 5. It's gonna, hopefully it sticks. The mental breakdowns, bro. Okay. And labels. We gotta label them. You have the cis-GOLGI network. And then you have the cis-cisternae. You have the medial cisternae. And then you have the trans-cisternae. And then you have the trans-GOLGI network. Okay. So far it's working. Now we will write the pluses and the minuses. Here, I think it was sorting. First, was it nano? You phosphorylate the oligosaccharides on the lysosomal proteins. Oh, what is my hat? Wait, let me just change hats. Hat to. Okay. Sorting, you phosphorylate the ones on the lysosomal proteins. And then you add, what's the next one? Oh, no. Minus mannose. And then this one's minus mannose, but add glac. Add nag. Next is, what's this? It's double green. Plus gal. Yeah, and plus nana. Then you sulfate something the tyrosine. Sulfication of tyrosine and the carbohydrates. and after that, it just gets delivered to the lysosome. I know this one's secretory vesicle. What's the middle? Plasma. Hello, Cheesecake Cactus. OMG. Thank you. Welcome to the stream, by the way. Oh, this is so cool. How does that work? Okay, thank you for coming to the stream. This is about the GOLGI apparatus. Wait, I have to introduce myself. Hi, I'm Millennium, Isekai'd Mask Knight, Empress Scientist, and I usually do Palworld, Pokemon, science. I sometimes do like reading Q&As or studying while on a treadmill, because why not? And then I do jumping jacks as well. So it's fun. Hi. Yes. Hello. Yes, this is what we do. It's the world of my brain is composed of food, jumping jacks, Palworld, Pokemon, science, and anime and Kdrama. So far, and heart rate monitor. Thank you, George, for the reminder. The heart rate monitor it reveals a lot of things, especially when there are shinies in Palworld, because you will see, like, even if sometimes my voice or facial reactions try to like be a stoic ice, like a stoic ice authority figure, the heart rate monitor goes doki doki. So that's what we do around here, and we're talking about proteins right now and how it gets packaged in the Amazon center of a cell, aka the Golgi apparatus. So we know, right, that it starts from the DNA and then you transcribe it into the mRNA. Well, I'm alright. DNA to mRNA. And this one happens in the nucleus. And then you process the mRNA and then you deliver them outside. And then outside, you make them into proteins. And this part specifically, yes, and this part specifically is this is where the ER is around here. Because the ER is rough ER or smooth ER. And if it happens in the rough ER, that means it's like the ribosomes are stuck in the rough ER, and then after you make the protein there, they can go through this pathway. They can. It's a can, because it depends if they have the appropriate signals such that they get delivered there. Yesterday we talked about how the proteins get directed to the what was it? It was the middle was mitochondria. Sorry, I'm very visual, so I gotta write it down. It was 3. I know we did 3. This is the mitochondria. It was mitochondria. Oh, it was ER, and then it was the nucleus here. And for the proteins to get delivered here to the ER, it would need to talk using the Sec62 or Sec61, especially with the signal something, the SRP, and then it would talk to the receptor, and then after talking to the receptor, it goes now to the ER. Mitochondria is funny because it has this one, right? You have the mitochondrial, you have the intermembrane space, and then you have the mitochondrial matrix, and then you have the space here, the outer membrane and inner membrane. So this is where the Tom and Tims come in, because your protein has to talk to numerous Toms and gets delivered through the Tims, and Tom is translocase of the outer membrane, Tim is translocase of the inner membrane. And the naming scheme I thought was like, oh, this one's nice. At least it's hopefully easier to remember. And then the nucleus is a different story, because that one is about, what's this one? Who was this? It was the NPC, nuclear pore receptor. So yeah, that's and a certain signal as well. So that's the mini summary of what happened yesterday. And today we are talking about the GOLGI. Yeah, we yap about science here. Or the best ice cream flavor. And please don't tell me that it's mint choco because that's wrong. Respectfully, no. Yes, the region of ribosomes. For the best ice cream flavor, that would be mango. Mango. Not I don't like ube. It would be mango or cheesecake. The strawberry cheesecake. Or what was it? Vanilla. Those three. I'm missing something, I think. One, two. No, as long as it's not mint choco, I'm good to go. Or not mint. This discussion happened because of the ice cream song that got stuck in my head. Now it's like, choco mint, strawberry, and what's the third one? Cookies and cream. That was the one I was missing. So it was cookies and cream, mango, strawberry cheesecake, vanilla. Those four, I'm fine if one of those win. As long as it's not choco mint. No. Okay, going back to GOLGI apparatus. We finished cis GOLGI until the trans. Protein sorting. This one's the clathrin coated vesicles and snares. Okay, we need a picture for this. Okay, there you go. 2 main pathways for protein secretion from the trans GOLGI network. Let's see. Let's see. Here, here, here. Erase. Alright. Now, let's start with... Where's my pen? There you go. 2 main pathways for protein secretion. Oh, this is the ending. This is the ending part. The last episode of the anime. Because they would deliver it from the GOLGI. This is the ending part where... I need to draw it. So it's gonna be a different angle this time because of the picture. But their GOLGI would be here. And then there's the last part. I'll just try to draw the picture. Okay. You have the constitutive pathway, unregulated, or the regulated secretory pathway. So you have the blues and the reds. The blues and the reds. There you go. Okay. And then, which one's the constitutive? Wait. It's the top one. The blue is the constitutive pathway. Constitutive. So the proteins and membrane lipids are synthesized in the GOLGI and are continuously transported to the plasma membrane via vesicles. Via vesicles. Where is my vesicle? They are cars. Via vesicles. Nope. Blue. They just get delivered there and then merge with the plasma membrane for outside to deliver them outside. They merge this way and then they're just here. Oh, wrong. And they're just here. Now, if it's the regulated secretory pathway, regulated, you have your secretory vesicle. Another car. The main fun fact, its another name is exocytic pathway. Really? Which one? The constitutive or regulated? Which one? Constitutive. These are keep those fun facts up. These are really good information that I really need because I need to be able to yap and explain about these. And then so that's why we're doing a lot of these science streams these days. And so the yap practice is needed. Okay, regulated pathway. Proteins meant for regulated secretion, like hormones, neurotransmitters, and digestive enzymes. They're stored in the secretory vesicles, those specific cars, and they remain in the cytosol until you have a signal like a hormone. Like a hormone which tells it, which signals that car to go. Upon the signal happening, this vesicle would attach there and deliver their thing. Voila. Oh, that's beautiful. Constitutive and regulated secretory pathway. But I have to... I'll draw it again. I'll draw it again. Just to make sure that it's in there. There's it. Again. Whoa. Whoa. No. That's a these nuts joke. No. I almost read it out loud and I was like, no. Okay. Now we're gonna talk. I'm gonna draw again the two pathways for protein secretion from the trans-GOLGI network. Let's see. Trans. Oh, welcome to the stream, by the way. Cool Kid 24 Knit, who started off with a joke. Two main pathways. Pathways for protein secretion from the trans-GOLGI network. The trans-GOLGI network. N. All right. So we have the GOLGI here. Some squiggles. And then two cars. And then the plasma membrane. Yep. And merging here. Merging over here. So we have the constitutive or regulated pathway. Oh, no. That's gonna be red. That's gonna be red. Regulated. Your proteins here and proteins over here. If it's the constitutive pathway, it's going to be delivered just normally. It's unregulated, so it just happens. Now, if it's this, what's this called? If it's the regulated, you need your signal. You need a signal like a hormone. After the hormone attaches to, say, like a hormone or neurotransmitter, after that one happens, it's going to tell that that signaling the car to bind, and then boom, you get your delivery here. So that's how it works. All right, that's how that part works. Where is it? Just reviewing the mini parts now. So the key takeaway is constitutive secretion. It's continuous and unregulated. So you maintain the plasma membrane and secreting. You secrete the essential proteins. Meanwhile, regulated is regulated. You will ensure that proteins like the hormones and neurotransmitters are released only when needed. So you don't waste resources to do that one. Okay, then you have... There's also two pathways for sorting proteins in polarized epithelial cells, like showing how the trans-GOLGI network would direct the proteins to very, very specific domains. Okay, let's see. Because that one could be direct or indirect via the endosomes. So it really, really depends. Again, it depends. Let's see. Erase. Why is there so many things happening inside the human body? And even if it's not the human body, there's still a lot of things happening. Wow. It's okay, you know, it keeps us alive. It's fine. If they don't happen, we're dead. That's okay. Okay. Now, two pathways. Direct sorting, or indirect sorting, via endosomes. So proteins are sorted in the left side, table time, straight line time. Direct sorting, this one is proteins are sorted in the GOLGI network. GOLGI network. Oh, let me change the hat. Hat time. Hat. Okay. Proteins are sorted in the GOLGI network and they're directly delivered to their destinations. It's like Amazon. Boom. Just deliver it. Precise delivery. Meanwhile, the indirect sorting, they are first delivered to the basolateral membrane. So you put them into a warehouse first. What's that term? Not it's like drop shipping, maybe. So you put them into the warehouse first before you route them. So you put them into the basolateral membrane regardless of their final destination, and then the proteins destined for the apical membrane are then retrieved via endocytosis and sorted into the basolateral. I think a picture will help. Hello, Sheriff. Greetings. Welcome back to the science stream this time. That we are discussing the GOLGI apparatus. Oh, by the way, I finished 120 jumping jacks again today, so that we are on our 6th set out of 10. But since I think it was yesterday, we reached like 13,000 subscribers. Whoop whoop. That means I'll do it 11 sets because it's gonna be 1,300 jumping jacks. And we are at set 6. That means we have done 600 jumping jacks. Wow, that's crazy. I didn't do all 600 in one day. No, I split them up. Slowly but surely. Road to muscles. Yes. Hello, Decipher. Welcome to the stream. Yeah, road to good stamina. I just wish that if I do a 3K run that I don't get so exhausted at the end or in the end. Like, yeah. That's just the goal. So that's why we're doing jumping jacks and maybe treadmill, but after the treadmill ones will be maybe after the some of the lessons, so I need to get through them. But yeah, so it will be direct sorting versus indirect sorting. Direct sorting, indirect sorting. And you have the picture. I will draw cells. You have the brown here. You have the nucleus. And then this one will also be a cell with nucleus. Look at that. Perfect circle. This is art. This beautiful art. You can't see it, that you won't be able to see this anywhere else. The perfect circle. And then hello, George. Hi. And then where's the red one? Okay, this one's the GOLGI. GOLGI is an avant-garde art dab. This one's GOLGI network. Let's just say this is GOLGI network. You just deliver the proteins directly. I'll just write the arrow. This one has pretty pictures. You just deliver the proteins this way, and then boom, you put them outside. And then you have proteins this way, and then boom, you put them outside. This is the basolateral transport. This one's the apical transport vesicle. Those are just different phases of your cell. Indirect sorting would be, I mentioned earlier, they are first delivered to the basolateral membrane. Okay, what does that mean? So, the arrows would go here, the reds and the blacks. You go here, first delivered to the basolateral membrane, and then if it's destined for the apical, the endocytosis stuff will get it, and then it's rerouted there. So I don't like the indirect but but this one helps, like it allows recycling and fine-tuned regulation of protein localization. Interesting. Interesting. All right. So now membrane recycling. The GOLGI apparatus, it again, we mentioned it has a lot of functions, right? What was its three functions I mentioned earlier? It was protein modification, protein sorting, and membrane recycling. Oh, okay, okay. Good, 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 good. The Golgi apparatus plays a key role in the recycling and through regulated endocytosis and exocytosis, as well as the anterograde and retrograde vesicular transport. Your steady state size and composition of the Golgi apparatus and other organelles are maintained. Okay, beautiful. Oh, I can actually draw this now from the nuclear envelope. It's nice you're using the chunking method by remembering it. Yes, I'm trying to remember it slowly. It's the I think it would be the chunking method plus what's the chronological method, and hopefully what was it? It was the castle, something something castle, the walking castle. If we just need to put this in our brains. My any method would help. Ugh. Mind Palace, yes. Oh, that works out lore-wise. Oh my gosh. Because we are an empire. This is an empire that we're building. And look at that. Look at the background. That's... Oh, I could actually... Can I erase that? 1 second. Look at that. That's the background. I think this one, right? Yeah, that's the background behind it. Look at the beautiful castle. That's the castle. Have I ever shown this? I don't think so. And if I move here, oh, I can't. It's not tracking me. I'll move my character then. Is if I move here, there's a chair as well, and there's also a throne. Yeah, I know that's the background. I will in the rumored debut stream. I will put these there as well, so it's like a room tour, even though it's not a 3D one. But that would be beautiful. But this is the castle. Okay, where is my thing here? There you go. Oh, not that one. Wrong one. There, that was what I wanted. Yeah, that's the castle. Oh, Warhammer. I also... Where is it? I'm not sure if the eye stinger was clear. Let me see. Is the background and logo only. Dun dun. See? That was the stinger. Again. Dun dun. Look at that. It blinks. Oh, I'm distracted. Focus. Focus. We will now draw from the nucleus to the plasma membrane. So this is the nuclear envelope. Nuclear envelope. And this is the ER, with the squiggles. The ER, squiggles, ER. And then you have your Golgi over here. Golgi. And then you have the endosome, stinger. Oh, that's true. I don't know actually. It would be funny if it's stinger. Our dear friend Google will help. Is it stinger? Stinger. Now I can't sleep. Stinger. How to say. How to pronounce. Stinger. Yeah, it might be the B. Stinger. Oh. Okay. I think it might be stinger then. You know, how about we make a different name for it? The eye cut. Just the eye cut. I call it eye cut. Because we're not sure which one is it. If it's the B one or the not B one. We have the endosome, and then we have the lysosome. This is the whiplash. It's like that one, and then now it's this one. That one, and then this one. Oh, it tracks it. It works. Hmm. Okay. You can go different ways. I see. Sorry. Okay, endosome to lysosomes. And then you also have this. We are in the cytosol right now. Then you have the secretory vesicles. And then you have the plasma membrane. Whoop, whoop. All right. This one's talking about the anterograde and the retrograde and endosomal trafficking. This one will have a lot of cars. Imagine this is either Manila or New York or LA or downtown LA. It's those. The lots of traffic lights. Sometimes the traffic lights are broken. And you will just hear beep, 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 beep. And then you are now stuck in traffic for 3 to 5 hours. Sad. Anyway, let's go with anterograde. The forward first. Forward. Hard passageways, yeah, especially. Which one would it be? Like the EDSA, I think, would be a bad one to get stuck in. And then, or New York Avenue, that would be messy also, depending. So yeah, they're similar, very similar areas. It just depends if you have free air conditioner outside. Sometimes. That's why I know that some people, for example, if they need to go to work at around 8 or 9, sometimes they would need to leave their house at 6 or 5 because of the traffic. Yeah, that's why. But if you try to walk from your house to work, then that might take 12 hours. So it might be a harder task. Side note, did Pinoy Big Brother already have an ending? I've seen some videos about the final Big Four duos, and it's pretty interesting for those who watch that. Oh, anterograde red. The anterograde is red passport, red transport. How are biology even working under its non-stop function? I know, and then take note that if you don't sleep enough or drink water, some of these get screwed up. So that's why you feel bad. Golgi. The red arrows would be like this, and going this way, and then going this way. This is forward from the Golgi, and then you go to the secretory vesicles to the plasma membrane. Oh, yeah, this is called exocytosis also. And then the late endosomes would be you degrade. This is anterograde. And then you have retrograde from here, from the endosomes going back. This would be Golgi back to ER via Copi 1 coated vesicles. Cop 1 vesicles to ensure proper protein recycling and quality control. Alright? And the plasma membrane proteins could be endocytosized. That's a funny word. Endocytosized into the early endosomes for recycling or degradation. Okay. Now, we have a green arrow also. Plot twist. So early endosomes. Oh my goodness, I didn't write it. This is the late one. And this is an early endosome. Okay. This one, you might have some proteins here going that way, and then going to the lysosomes. Are you somehow interested in natural science too? Not just interested, I may in fact be in the natural sciences as well. So that's why. Oh, I forgot to mention. Wait, the introduction usually I do that I always forget, even though I say I usually do it, is hi, I'm Millennium, Isekai'd Mask Knight Empress Scientist. So, and that includes the natural sciences, natural and life sciences. Yeah, that's the thing. The Isekai one would cover a lot of the anime stuff. Mask Knight would also cover a lot of the anime stuff. The Project Aincrad agenda is strong. Sword Art Online is the core of. Look, I literally have two swords. The Mask Knight part, did I? Oh, wait. I actually have a mask. There you go. See, I use that for when I need to dive into games. That one's the mask. And did I? And the microphone, if you see it, that's usually for the rumored karaoke streams. One already happened. It was unarchived, so that's why if a karaoke stream gets announced, please join live because I'm scared of copyright. So that's why I just unarchive them and check which songs are allowed. I don't know which one they allow. So because yeah, always the amnesia. Yes, it happens, especially if you've been living on Earth for 1,000 years. It's tough. And in the isekai realm, you restart each time, right? So you just add it all. And then this is the controllers. That one. I have to. Yeah, in the rumored debut stream at some point. I will show these, but there's a mini. What's this called? Spoiler. Look, there's also this reaction. The womp womp with the eyebrow. And then there's this one, the crying. And then what's this? Oh, this one's the angry one. I don't know why it jumps. I think if it's a scary thing. If you forget what's the definition of CRISPR. Yes, this is a, like someone forgets that mitochondria is the, what's this called? Mitochondria is the powerhouse of the cell, and they're like, no, it's not. You're like, yeah, that's how it goes. And there's this one. If a shiny happens, shiny. And then I think that's it. And then, oh, and this is the gold crown. Gold crown. Yay. So that's a mini thing. But I will, in the rumored debut stream that will happen at some point, I will bring those up. If I don't remember, if I forget to note it in the non-existent PowerPoint, feel free to remind me. Wi-Fi in the Philippines is too slow. Oh, the PLDT, I know. Oh my gosh, that depends on which one, but I know what you mean. It's either you're fighting the Wi-Fi or the brownout. And there's, I think, in a soon-to-be-released highlight video, you'll see that there was actually a time I found a 99 defense jet dragon, but sadly, the Wi-Fi disappeared just when I was about to catch it, and thus I was not able to catch it. It disappeared. So that's what happens when the Wi-Fi is not working with you. Okay, so we have two passages of the proteins through the Golgi. You have the cisternal and vesicular transport model. Really? Wi-Fi Kun. We should have a mini picture for Wi-Fi Kun. It's Wi-Fi Kun. Hi. Wi-Fi Chan, I think, would be cuter. Wi-Fi Chan. I just imagine it's like Miku from Quintessential. It's shy. It happens. It's brown out earlier, now based in the deduction, the reasoning that you were in the Philippines too. Yeah, it's half-half. I could literally be behind you. Don't look. But that's the thing that's happening. So yeah, the isekai I did Sanji. I didn't watch One Piece, but I know of Sanji. Yes, I did. I do know of like a lot of my friends watch One Piece and is a collector. Wi-Fi Kun, Wi-Fi Chan, and FPS Chan. Oh, my best friends. They are the, but oh, I need a character for them. FPS Chan is funny because if FPS Chan hides, then DPS Chan increases in power. Yes, that is a law, not just a theory. It has been proven. We've defeated Blazamutryu before using that hypothesis. So it works. It really works. And what works? The passage of proteins through the Golgi. And the two models for it has been like proven or is being used. It's the cisternal maturation model maturation or vesicular transport model, right? Here. Okay. This one is interesting. So in the vesic what? The labels are weird. One moment. This one's vesicular. Vesicular and cisternal. Let's go with vesicles first. Vesicular and cisternal. We don't talk about FPS Shan. He goes up ranking grind days and comes back on chill gaming. I know, it's very unpredictable. Ooh, thank you, George, for the membership. Oh, did it work? Or do we need to wait for the, what's this called? For a few seconds before the hype train thing responds to it? Because that's why I wanted to like double check if it works. I know at least that the code for the custom chat works, but I wasn't sure if the hype train works. I would like it to work because I feel like it has 5 levels at least, and it depends on the level. Oh, it doesn't. It's a scam. Okay, if it doesn't work, then we just have to. I will refund it then. There, I'll wait for about like a few seconds, but remind me if it doesn't work, then a call for a refund might be needed. Anyway, for the vesicular transport protein model, secretory proteins enter the cis cisterna at the cis Golgi, and the proteins stay within the same cisterna. And then for the cisternal, wait, it looks the same. Wait, what? So vesicular, secretory proteins enter a newly formed cis cisterna at the cis Golgi. The proteins stay within the same cisterna and matures forward. Okay? If it's the cisternal, Golgi is fixed into sub-components, each containing specific enzymes. It's modified in each sub-component. It sounds the same. 1 second. 1 second. Google. Best friend Google. What's the difference between cisternal vesicular versus cisternal maturation model? Oh, since we got, let me see, I'll do 10 jumping jacks for that one because I had that mini rule before that because we're not doing Power World, so I can't extend the shiny hunt. But what I do know is that if it's on the treadmill, then the speed gets increased, and if I'm not on a treadmill, then we do 10 straight jumping jacks. So let's go. And okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there you go. So, okay, Google says the cisternal maturation model proposes that the Golgi mature as they move from cis to trans. All right. It's passive. Yes. Cisternal mature as they move from cis to trans. Meanwhile, in vesicular, it's stable and the proteins move between them via vesicles. Okay. Oh yeah, the passive XP gain, of course. It would be funny if I had I'm gonna remove this the hype train one thing because it doesn't work. It doesn't work, sadly. Even if I refresh, let's see. If I refresh it, will it work? Where is it? It's gonna be here. Google Sama. Yes. So we have how many characters now? We have Wi-Fi Chan. I don't know I remember correctly, but vesicular transportation uses ATP. Where is Google Chan, our best friend? Where is it? Because right now, the way I know it, let's see. Right now, the clarification we got would be, characters that we have is Wi-Fi Chan, DPS Chan, FPS Chan, our best friend. It's Shy. FPS Chan is Shy, and then lastly Google Sama. That's the big boss. Google Sama. All right. So for vesicular, we know. No. Cisternal. Cisternal would be they mature. Golgi cisternae matures as they move from cis to trans. All right. But vesicular means stable, and proteins move via vesicles. At least, okay. If it's vesicular, the proteins move via vesicles. We know that one. And then cisternal, it grows from cis to trans. Now, about ATP, Feynman method type. Hello, Zombilos. Welcome back to the stream. Feynman method. Yes, it does. Hopefully it helps. I need to learn how to yap about it. But don't worry. It's a part of the process. Yeah, that's why. Oh, we're now learning about the vesicular and cisternal transport and asking Google Sama about it because the notes are I switched around some of the columns and now I am confused. This is why business is better. No. You know, the business and science can interact. Biotechnology. The biotechnology is there. That's also after you make vaccines and all that, you would need to market it because some of those might be the same as the other ones. So you need to learn how to market it. So that's why both they're together. Same as how DPS and FPS work together. If FPS Chan is hiding, then the DPS would be stronger. See? They're best friends. Best friends. Alright. Cisternal suggests that the entire cisternae moves forward, while Golgi enzymes recycle backward. But vesicular just move them via fixed. Oh, wait a second. I need to write it. Who was the fixed and who was the not fixed? Vesicular is fixed. Fixed. Oh my gosh, I didn't watch it, but I like Ginu. No spoilers, please. But the song Soda Pop, oh my gosh, it's funny. Both the Korean version and the Tagalog version, I like it. Oh, no, I can't. I can't break into a karaoke session right now. No, I have to finish this. No. Be gone. Be gone. No Soda Pop right now. Oh my gosh, I didn't know Batman was there. Sedge. Okay, cisternal. Who was the fixed one? Okay, vesicular is fixed. They just move through the vesicles. Cisternal, they mature through and move forward. Yes, the fact Gino, oh my gosh. Okay, here's the thing. The voice actor for Gino is An Hyosop, the Korean one. My jam. But the Japanese voice actor, Isekai'd, my jam. Isekai'd is the same one who voices Naofumi in Shield Hero, so that's why I did upgrade my mic. Very good ears. I did upgrade the mic, and does it work? I upgraded the mic so that it won't catch, hopefully, the and positioned it properly with a, what's this called? An arm or something. So yes. And so let's say if even if I turn on the fan, there's the laptop fan, does it change the quality of the voice or no? There. The fan is now turned on. Is it did it can you hear it? Because compared to before, I think you could hear a jet before. So hopefully now it doesn't, like it won't make it obvious now. Yes, at least it works. So yeah, and you know what works? The vesicular and cisternal transport. So vesicular, that's it's fixed, and that means you just deliver the proteins. Yeah, I could not only hear a jet, I could hear the peeping of the jeepneys and stuff. Oh my gosh, not just the jeepneys, you might have heard some ambulances and all that. But hopefully not. No, I don't hear it. Even earlier when you said you turned on the AC, we don't hear it. Oh, that's beautiful. At least it works now. Because if you check some of the other streams, oh my gosh, you can hear the construction site, you can hear the ambulance where, and then I think I got asked about that before. I was like, just don't mind it. It's just the air. And then if I turn on the laptop fan, it's a jet. And if I turn on the AC, it's another jet. And if you turn on the electric fan, it's another jet. It's a very not treated room for this. It's just a fancy wind with the wee boom, 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 boom. So if you're used to playing Counter Strike, it's okay. Terrorists, the Counter Strike, yeah. So it's just outside. Oh, now we can now move to the selective transport and bulk models. The bulk flow model. Oh, okay. Bulk flow. You have the proteins. There are two types of vesicle transport. Yes, endocytosis and exocytosis. Endocytosis would be taking them in, but exocytosis would be putting them out. Bulk flow would be the proteins without specific. Oh, I have to table this one. Table it. Yeah, oh my gosh, if I do a watch party, would that work? I thought I saw some, like, I think Nick's Voltaire, I saw how he was able to do a watch party, and and then just so there's the time on the stream, like a time of like a ticking time that goes up, just so it would be in sync technically. Oh my gosh, okay. Imagine. Story wise, oh really? Okay, I'm gonna have to note that down at some point. After July, at least around 11 and above. I'm gonna try and set some stuff there. And there. Hello, Elmore. Welcome back to the stream. We are talking about the bulk flow model and selective transport model of protein delivery in the GOLGI, and was discussing the visuals and animation of the Kpop DH the movie, but I didn't watch it. No spoilers. It's just, but you're allowed to say if it's great or if it doesn't work. You're watching anime. Which one? Feel free to discuss if it's something I already watched. Example would be Quintessential Quintuplets. I finished it. I hated it so much. I do not want to look at it again. Bulk flow model. Here is bulk flow model and selective. Oh, I did not watch that, but it is on my to watch list. It looks pretty. It looks very pretty. Selective transport model. Transport model. There you go. Bulk flow proteins without specific export signals. Side note, I think I won't search it. It might add some cookies and spoilers. I was gonna search the voice actors for it, but no, not yet now. I need to watch it. It's really on the Mal is working. The Mal listing. I'm also aside from I have to list that down. I'm gonna at some point I wanna do a stream where I just yap about my completed my anime list anime. Yeah, that would be a funny one. Because the Isekai and the game to the moon, I didn't watch it. I am discussing the bulk flow model and selective transport model, where the proteins without specific export signals would just be exported through bulk flow, but the proteins with KDEL sequence, KDEL, would be retained in the ER. Retained in the ER. At ER. Oh, where's my sticky note? No, sticky note, sticky note. You also have the selective transport model. Again, this one would be packaged into vesicles. Drawing question. It depends on the question, but okay, feel free to try. Packaged into vesicles that direct them through later stages. Okay, so bulk flow is no. I'm gonna close my eyes. No select. Okay, one moment. Bulk flow model, proteins without the specific signals would just be shot out. Madam, you're drawing. What quest? Sorry, what do you mean? Proteins without a specific signal would just be thrown out, and the proteins with the KDEL signals would just be retained in the ER. Selective transport would be packaged into vesicles, and you just direct them specifically, and the ones that lack the specific signals would be put into the bulk flow model. All right, that works. Experimental design to test the GOLGI. The clarity. Hi, thank you very much. W mic. Yes. This is actually USB. I'm just trying to gather the energy to set it up as XLR. I have heard that XLR is much better. Yeah. And it's yes. Oh, what do you mean? It is USB. It's USB mic. See? It's really nice. Imagine if it was XLR. My voice actor ears. Like I needed because I like to review. Okay, to review some of the lessons. I sometimes go back to the scribbles that I do, and I hear the jet sounding, and I'm like, what's happening there? This is rough. So I was like, I gotta switch. I gotta switch the mic. This is USB mic with just proper configuration. And yeah, so that's the thing. Just how gathering the energy and possibly resources to connect with us XLR, because I don't have the interface yet. The USB was the easiest version to on like how to connect this one. Yeah, but thank you. Like the fact that the new mic is noticeable, that means that it was a worth it upgrade. Whoop whoop. And thank you for the members who are helping make that possible as well, because it just means that when there's a shiny in Pal World, we will be able to see and hear it clearly. If it happens, you will hear the gasp, the audible gasp. If not, just check the heart rate. It will go up. Sparkly. Okay, so how do we want to check if it's cisternal or vesicular? Because earlier, the cisternal, we mentioned that it would be... What was it? Cisternal was... Vesicular is fixed. Vesicular is fixed. It just means going through vesicles. Cisternal would be that the GOLGI matures as it goes through, so it moves a little bit and tries to deliver it. Okay. So, the setup could be put markers. Okay, got it. We use different markers. So what do we want to see? Erase, erase, erase. Here you go. What is the marker? We have the experimental design, right? Experimental. Oh, by the way, right now the laptop fan is on, but if I turn it off, will it make the voice clearer? I did. Oh, Saba debut. Oh, debut. It was so cute. And okay, fangirling. 1 minute. Set a timer. Okay, here's the thing. I was amazed at like how animated it looked compared to her non-existent past life, right? So that just means the rigging is much more like advanced. And I saw how the one who rigged it was the same rigger as the same rigger as Lime and Mint. 70-50K subs right out of bat. Yeah, the young stars. Yeah, but congratulations so much to Saba. I was very, very happy about like her newfound freedom and that she can now play a lot of the games which might normally require perms, right? Like in the event that she was still in a company. But yeah, saw her moving and I knew it was the one who rigged Mint. Exactly. It was the one who rigged Mint and Lime Malicious or Lime. So it was Celia. Celia, that's the name of Celia. Saba just fused from the two previous gremlins in. Yes, it would be from the yellow and the blue gremlin into now Saba if she was in a company, but Saba is now indie. Well, she is indie. The past life, wink. We don't know if there was a past life. Anyway, how will we do an experiment if we want to see if it's cisternal or vesicular? All right, we use the we use a couple of things. We can do live cell imaging. You look at the cells, live cell imaging with markers of GOLGI markers over time. How will we do that? You put tags on it. So for example, what's this? You use, let's say you have an early GOLGI, oh, I know this one. Early GOLGI marker, late GOLGI, middle, and a late GOLGI marker. Okay? So if your markers, let's say these are squares, right? Oh, that's perfect. I'll just put them under the cisternal and vesicular. So, if the theory is, remember, vesicular is fixed and that they just get delivered. Isn't it summer vacation? Oh, here, you know what? In some phases of the educational system, it might be summer vacation for some. It might be like you have advanced classes for some, and sometimes you're just crazy and you just like do it. And sometimes you just need to get through a really, really important thing that which is heart inducing. So that's why the resting heart rate is 90 and above. Yeah, one of those might be the thing, but feel free to keep watching the incoming science streams that I gotta really do, especially in the next few days, like about 7 to 10 days. Ugh. Your summer started a month ago. Congratulations, very congratulations. Feel free to eat the mango float and the lechon and the mango shake and the halo halo in lieu of the people who don't have a summer. Summer is everywhere, you know. Time zones exist. Also, if you keep on isekaiing here and there in the South Elysium, in the West Elysium, it sometimes disappears. Summer, winter, spring, and fall, those would just all merge, and all you see would be day and night, like in Pal World. Day and night, and if it's nighttime, you try and catch the legendaries. If it's daytime, go to Favorite. Yeah. Now, if it's early, so the markers glow, right? Okay. Now, if it's cisternal, the one you see where they mature, how would you track the movement? The IRL mechanic. Yeah, exactly. How would we track the movement? So in the cisternal, if it matures. We might see it at first, but after a certain time point, it might be here and then it might be gone. But in the fixed, you should be able to see it in like 2 different time points. Okay? Like see the same thing. Did that make sense? Because I got confused. One moment. So if it's mature, let's say which one? Early marker and late marker. Oh, okay. The late marker should appear and the early marker should disappear if it's the maturing model. But if it's the fixed model, aka the vesicular one, then it should still be there. Thank you very much for confirming that it makes sense and also it doesn't make sense. That's oh, I think the mic was covering the camera or the tracker. There you go. Eye tracker. The eyebrow tracker. Okay. Next. Nucleotide snare mediated fusion. Wow, okay. This one's about docking. That's why I wanted to save the GOLGI apparatus lesson because this one is this one it requires numerous yapping. But I wanted to yap it all in one go. Because why not? If I was crazy, I would try to attempt the remaining jumping jacks in one go. The little squishies. Oh, how many are they right now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, it is quite a complex topic because it's very, very detailed. That's why. But it's the important topic that I need to drill in my head. I have to remember this. So if you remember it, please. If you have questions about it, just try or try to remind me about what happened 10 minutes to 30 minutes ago. Feel free to do that because it would help me review this as well. Don't worry, we have a couple more binders after this one. I don't know how long I will be live or until after my voice says rest. Forcefully rest. And I also have water right now. So, vesicular traffic. We have biochem and MCB. 2 things, molecular cell biology, those 2. So you have nucleoprotein. Oh, table time. You have mechanism of vesicular topic. You have 3. You have the nucleoprotein driven vesicle formation and lipid composition. Wow. And coat protein. So nucleoprotein, this would be the first type, which is about the binding. What? Wait. The font 8 is not helping for someone who has nearsightedness. So even if the notebook is near, you have to bring the notebook to 4 inches from your eyeballs. The first type involves the binding of a nucleoprotein particle to a viral encoded membrane protein. What? Binding of a nucleoprotein to a viral and they bind. Binding of a nuclear protein to a virus protein. Okay. They're friends. Lipid composition. This is the formation of a bud or vesicle driven by a difference in lipid composition between the 2 monolayers of a membrane. Okay, what? Involves the formation of a bud/vesicle driven by a difference in lipid composition between 2 monolayers of a membrane. You have different Rhabdoviridae. That's a specific type of virus, right? Formation of a bud or vesicle because those are different. Okay. Coat protein. Binding of coat proteins to the membrane. I think I like the third one best. Now, what about the snare-mediated fusion? That's the only term I know. It's okay. You can add the word CRISPR into the mix. Clustered, regularly interspaced, short palindromic repeats. Whoop whoop. clustered, regularly, interspaced, short, palindromic, repeats. Yes. That's CRISPR. I think I explained ultramicroscopic silicovolcanoconiosis. Yeah. I know that one. That's the word that I kept on memorizing at the back of my head, and finally today's the day that it became useful. Ha ha. Ha ha ha. And the supercalifragilisticexpialidocious. I like the Numino Ultra one. Numino ultramicroscopic silicovolcanoconiosis. Oh my god, did she just rap? I did. That's also why I also did the rap of in the beanie one. I felt like I'm studying in high school again. Thank you. I was gonna say congratulations and thank you at the same time, but no problem. This is also helpful for me, especially with the fun fact questions and the snare ones and supercalifragilisticexpialidocious. Ha, muha, ha, har har. I think the Numino Ultra one is a scientific word. Oh, I was gonna say regarding the rap, that's why I did the in the recording for the Breaking Dimensions one, which may or may not be it might be being cooked right now. But I like the rap part of that, and I also like the rap part of the Salamin Salamin. What was the I'm gonna find the lyrics again. Oh no, I cannot. I should not. I'm this close to just doing a karaoke stream right now, but I'm like no, not yet, not yet. Breathe the eyebrows. Okay. Snare mediated vesicle fusion process. They're essential for targeting for intracellular vesicular trafficking, particularly for fusion with target membranes. Or by the way, when I finally decide on the specific date for the karaoke stream, hopefully we'll all be there, right? Whoop whoop. But yeah, I'm trying to decide on a specific schedule for that. If there is a schedule that it's an imaginary schedule, it's a Schrodinger schedule. The schedule. Yeah. Vesicle docking. You dock them. You park. It contains the V snare and RAB GTPAs. Assembly of the T snares. Hi. Thank you very much. And then membrane fusion and disassembly of the snares. This one, we will have to draw this. But yeah, waiting rooms will be posted. And here you go. Vesicle snare. Did I write it? Snare mediated vesicle fusion process. Oh, I remember the salamin rap. Bakit pa pasikot-sikot para bang pinapaikot-ikot talaga magets ano ba talaga ang next move mo? That one. It was Beanie Stacy's rap. Or Mika. Stacy or Mika? What was the other one? Salamin rap. Salamin rap part. Rap part. It was no. Where was it? No, don't. Yeah, I was gonna. No, I will not. I no. It will be saved for the karaoke stream. Not yet now. Snare. You dock it. V snares will be there. Assembly. Okay. Next. Oh, we did the Kpop 2 and Kpop 1. Kpop 1 would be the one going back. It's GOLGI to ER. Kpop 2. It's one like this. I will clarify it by drawing it again from memory. So you have nucleus, and then the ER, and then the GOLGI, right? Wow, beautiful. Okay, so the arrows going back. This is Kpop 1. This is retrograde. And the arrows going forward is Kpop 2. This is anterograde. Beautiful. Okay, just remember that. And then you have clathrin to the endosomes. Nice. Finished with that one. Oh, there's also the Nicki Minaj's rap, which was this one's for the boys with the booming system, tap down AC. That one's funny. I like that rap. It would be in the radio. The radio stations would play that. Okay, finish this part. We finish the dock. Grab GTPAs, T snares, fusion. You dock, you assemble, you fuse, and you disassemble. Nice. In the first study streams, did you actually? I ate a bit between those, so maybe it would be 4 hours, and then eat for about an hour, and then study again for the rest of the 5 hours, and then once I get a headache, I would try to rest. But yeah, but I learned that I can actually set up a mic, so I was like, okay, then I can. And if the Feynman method is actually helpful, because I need to yap about it. That's just the mini. It's not the TLDR. I gotta practice yapping about it. So yeah, Clathrin and non-Clathrin quotes. Non-Clathrin, Cope 2, Cope 1, Claviolin, Erlich, Note Self, T snares, V snares, a lot of snares. Okay, sorting signals. Yeah, this is the life of a literal, the maybe perhaps a literal budding scientist. You know what I mean? Yeah, it's in the rumored debut stream. The details might be there after we get through this, if we get through this. Anyway, Kdel sequence. I kept on mentioning Kdel. But what is that? I think it's lysine aspartame. No, not yet. Maybe not. Lysine, where's it? Kdel sequence. Who is that? Lysine aspartate, glutamate, and leucine. Okay, good. I will write it here. KDEL, aspartate, glutamate, and leucine. It's at the C terminal of proteins. All right. What is it about? It ensures the retrieval of ER proteins back to the ER. Going back to the ER. Okay. Back to the ER. Wait, ang tubig muna. Water. Okay. The nature spring mineral water goes hard. Not nature spring, but similar to that. All right, so we have the Kdel sequence. Wow, that was nice. I should have drank water earlier. Lysine, aspartate, glutamate, leucine. Okay. We did it. But draw it now. Kdel sequence. Lysine drawing. Lysine structure. Oh, I see. Lysine is the one that I thought asparagine was. This one is N8. No? H2N, yeah. COOH. Lysine is the CCCCN H2. Yes. Queen, Stan, whoop whoop. Yes, H2. By the way, you know that C carbon, you just add 4. It's normally it has 4. Nitrogen normally has 3 bonds. Okay. Aspartate. Has oxygen double bond. I think. Aspartate. Yeah, this one is CHCOOH H2N. This one is. Where is it? Where? NCOOC COOH NH2. Oh, it's here. Cannot see. It should look There you go. C. Oh, I think it's just C minus bonds. Covalent bonds. Yeah. I'm trying to angle this picture. Oh, there you go. CH2COO. COOH. Okay. Huh? C double bond O COH. Okay. Wait. That's why it looks weird. Because I was used to drawing it this way. But it's COOH. So, glutamate is just longer. Yes. Slay. Okay. COOH. H2N. CH2. CH2. COH. Double bond O. That's why. And then COOH is literally just C double bond OOH. Lomeo. Okay. Got it. They're trying to cast the new James Bond right now, and Tom Holland and Jacob Elordi are on the potential list. Is that real? Wait, what? I don't know. Okay. I think it's possible. But why? Why then? Well, I'm trying to imagine it. I think it would work. It would work. It might work. Wait, leucine structure. Right now? This one is. Okay. C and V. C. Alright. Now, we draw it. I can't lie, they got... Yeah, I was trying to keep my face as stoic as possible, but maybe a different one. Or it depends, they might pull it off. Kdo. Imagine if it's the one who played Zoro in the One Piece live action. Makenyu. I know Makenyu. Maybe? No. I don't know. This is lysine, aspartate, glutamate, and leucine. Okay, that one works. Well, side note, I don't know if you can hear, there is the background music, but I can make it louder to make it more hype. There's some more science hype. There. I think it's... There you go. Slowly, it's gonna work. Lysine. Alright. What was lysine? CH H2N COOH O. Science hype. Yes, we need to make it as hype as possible. I want to hear it actually. I don't want to make it too loud. Just enough. Yeah, there is. It sounds so hype right now. That is the anime life. Okay. COOH, H2N, H. Oh. What was this? What? Lysine. And it's positive. Where was it? Lysine structure. Oh, the long one. C and H2. Okay. Aspartate is CCOOH, H2N, and H. This one is C, H2, COOH. And this one is CH, COOH, is H2N. This is CH2, CH2, COOH. Good job. COOH. This is the positive reinforcement. That's why I'm called crazy sometimes. COOH, H2N, and H. And C. Good. Very nice. Beautiful. All right. Keep that up. Kdal sequence. Kdal is there. What is the Kdrama sequence for? This one is to make sure that the ER proteins are put back to the ER. Okay, good. Good job. Nice one. Very good. Lysosomes. Oh no. The janitors of your cell. They are spherical organelles surrounded by a single membrane. Primary lysosomes are small, secondary are larger and contain partially digested material. The transfer Mannose 6 phosphate, okay. Maturation, coating. Alright, we did that one. Ooh. Biosynthetic pathway. Lysosomal enzymes are synthesized in the rough ER, yes. And it's modified with end-linked glycosylation, yes. In cis Golgi, the mannose are phosphorylated, yes. In the trans Golgi, M6 are recognized. Okay, and put them there. Back trans Golgi, and then endocytosis, the exit or inside. Oh, endocytic pathway. Some lysosomal enzymes are secreted but can be retrieved. It's the retrieval. Endocytosis is through clarithin coated. Low pH dissociates. Alright. Next. Rough ER. Clathrin mediated trafficking of lysosomal enzymes via M6 phosphate receptor pathway. No, more arrows, no. No, fine, oh. Okay. Will do. Fighting. Okay, let's draw it. Here you go. Okay. This is clathrin mediated trafficking of lysosomal enzymes via mannose 6 phosphate receptor pathway. Nice. Okay, so we first sort in the trans Golgi. We know that. The trans Golgi, I'll draw it here. This is the trans Golgi. You sort it there. The newly synthesized enzymes receive an M6P tag. So the ones who have an M6P tag are put into here. And then the vesicles bud off from the trans Golgi. And then they shed their coat and they fuse later on. Whoa, this one's a long travel with a plasma membrane. Okay, that one's good. Then you recycle the receptors. And the receptor mediated enzyme. Okay. Just put them back in. Clathrin and diffuse. Okay. Now you just recycling the receptor essentially. Now, for non-lysosomal proteolysis, you would need protein degradation that occurs. So what is non-lysosomal proteolysis? That would be protein degradation that occurs outside of the lysosome, especially through ubiquitin protease system, okay? And unlike lysosomes that degrade the bulk material and organelles, non-lysosomal proteolysis is very selective and just degrades the individual proteins in a regulated manner. Okay, adunice. Ubiquitin proteasome system for protein degradation. They're marked for degradation by ubiquitin. Oh, this one reminds me of the Wnt signaling pathway, which I will try to yap about now. Just as a review. Why not? This is the Wnt pathway if it's off and Wnt pathway if it's on. So you have the Wnt pathway. This is your cell membrane. Again. Yeah, the Wnt signaling pathway. I know all about, of course. Yes, the Wnt signaling is our friend Wnt-chan here. Okay, now we have this one called, there's a thing called the frizzled receptor. And then you have your LRP receptor. That one, right? So, if the Wnt, oh, and you have your beta catenin, just focus on this part, beta catenin. So you have your Wnt. If there is nothing that goes inside here, then that means your beta catenin will be degraded by the APC and stuff like that, because you have the axin and the CK and GSK kinases. These would add phosphates here, which would then call a thing called DSH. And with that, oh no, that one's if Wnt is turned on, I think. Yeah, if that's the case, these two will phosphorylate your beta catenin, which will then, wow, I want to make sure I don't switch this up. Oh my gosh, I forgot which one was which, if it's the off or the on. Where is it? Left erase first. All I know, let's start here. It depends on if we phosphorylate beta catenin or not. Where's the, I had a photo of it before. Wnt. Okay, there you go. So, if Wnt is inactive, it would phosphorylate the beta catenin. It would phosphorylate our beta catenin. And then that means it would be ubiquitinated and then be degraded like that. 1 mil% of neuroplasticity right now. Yes. I will actually be talking about the neuro stuff later. So, or later or in a few days. It depends on which one. Oh, it would be nice if it's later, but I have to go through cell signaling and cell cycle first before we reach neuro stuff. Neuro-sama, the boom, new song of Evelyn. Very nice. Very, very nice song. And the comparison between the life and boom statistics, I admit I have listened to boom at least 5 to 10 times. It's very, very a very cool song. It's very nice. But you ubiquitinate this and then eliminate it. But then if you actually, Elif is it's the tsundere, especially when she got flowers for Vedal. Very nice. I watched some of their clips. That's why Boom is really nice. It's like both of them are having existential crisis. For example, Neuro's like, why am I here? Why am I an AI? And then the life song happens, like, oh, friends and all that. Meanwhile, Elif is like, haha, boom, pipes, boom. I think the second song should be pipes, honestly. I thought it would be pipes, but boom was cool. Okay, if you have Wnt signaling, if the Wnt ligand binds here, then that would trigger the destroyer complex to be destroyed, because the axin and the GSK and axin would actually phosphorylate your LRP, the LRP, which then calls the DSH here, and your axin and APC would be split apart. That would mean your beta catenin can freely accumulate and then go to your nucleus. And what's inside the nucleus? Your DNA stuff, right? It goes to the nucleus, which then helps turn on the transcription process. So that's the difference between Wnt on, Wnt off. Endoplasmic, let's go through the ARAD pathway now. Endoplasmic reticulum pathway. Endoplasmic reticulum pathway. Erase this. Erase. Nice. Okay, so we have the ARAD. Endoplasmic. Oh, the little bouncies. I saw them from the second monitor. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cuties. Endoplasmic reticulum pathway. What's the A? Reticulum associated pathway. All right. The proteins that are not folded properly, the misfolded proteins would get delivered here. Their final house where they are just chopped. The proteins are sent for degraded there. They're recognized by chaperones and are directed to an E3 ligase. They are transported there. ER surface. Is it like the calcium chamber? What's the calcium chamber? One moment. Google some. Calcium chamber. Nani. Calcium chamber what? Used to measure the calcium carbonate content of soils. I don't think so. Yeah, misfolded proteins like Kurukreutzfield. What? Maybe. I'm not sure about that one though. I haven't heard of that. I forgot. Where do all proteins from the cell come from again? Where they? Oh, good question. So, remember this is the cell, and you have the nucleus. This is the nucleus. This is the outside. This is the side. Yeah, and then you go from DNA to mRNA to protein. And then we're just delivering them either to the lysosome, to the ER, to GOLGI or something. And then at some point, they could also go out. So all of them come from the nucleus. They kind of started as these. But that's also the DNA, that's the central dogma. DNA to mRNA to protein. That's the very big thing that you should not forget, especially in the world of biology. DNA to mRNA to protein. This is what's called the central dogma. There you go. And this pathway is just to chop them. Misfolded proteins containing cytoplasmic intramembrane or ER lesions. Lesions being, just think like pimples. They're recognized by the chaperones, and they are targeted to the translocon or ligase. They are initiated by certain stuff, ubiquitinated, and then just destroyed. Autophagy. Oh, the prion diseases? That's the brain stuff, right? I think so. It might be related to that too. The plague ink. That may be one of the games I have in the non-existent schedule that I have as a draft. Watch out. Plague ink and bio ink. Yes, the grind from bacteria to virus to fungi to prions, and well, the schedule. I just need to get through this thing. That's why, like the all of these stuff, and then at some point, hopefully, we're free. Types of autophagy. So I can't wait to finish the thingy. But yeah, I'm excited to play more Plague Inc. and all that at some point. I'm just holding back the right now. We are holding back the powers. But hopefully we do this safely. Right. Autophagy. What is it? Autophagy. Phagy? It's the process by which the cells, proteins, structures, and organelles are digested by the lysosome and their components are recycled. Oh! Teka, basurahan. No, not the basurero. So you destroy them and the recycling bin. Yeah, you destroy them and then you recycle. There is the micro-autophagy, macro-autophagy, and chaperone-mediated. Micro is the direct engulfment of the cytosolic components, and then macro-autophagy would be where the cargoes. Chaperone is just selective. Okay. Cancer. Autophagy acts in tumor suppression by removing damaged organelles But it is also a cytoprotective mechanism that helps the cancer cells resist anti-cancer treatments. What? Whoa. Autophagy acts. Really? How come is it why is it scary? Is it because of the pros and cons? Because in tumor, it can do tumor suppression by removing the damaged organelles. But it also acts as a cytoprotective organism because it helps cancer cells survive in conditions of low nutrient supply. Got it. Well, that's sad. Pros and cons. Voila. Okay, question time. Design an experiment to investigate the effects of blocking the first step of end-linked glycosylation. Include a method to achieve the block and how you would assess the effects. One more time. Design an experiment to investigate the effects of blocking the first step of end-linked glycosylation. What's the first step? Is it making the actual thing going from the dolicol phosphates and the NAG and mannose and glucose? We add tunicamycin, which express okay. To block it, you add tunicamycin to block the addition of the glycans. Then you express the OST mutant dominant stuff. So that prevents the glycan transfer without using a drug. As a result, if glycosylation is blocked, proteins should lack the glycans. Oh, that's true, because if you block the transfer of it, then the proteins that you see should not have the glycans. And I think to see that, you could do a Western blot or something. Let's see. Yeah, Western blot to check. Because if you do a Western with or without endo-H, endo-H cleaves the end-linked glycans. I want to write it out. Okay. End-linked would be end-linked glycosylation. What is it? This is the act of this is your protein amino acids, right? End-linked would be you put the sugar stuff here. So, if you put a medicine, is the drug, a medicine that blocks the transfer, that means the expected proteins won't have the sugar molecules. Okay? So, obviously, if we check it, it shouldn't have those. Now, if we perform a Western blot, it was this technique where you check the bands and you add with endo-H and without it. Note, endo-H is an enzyme which cleaves end-linked glycans. Okay, so it's expected that in the with endo-Ace, you shouldn't see these because they just destroy the ones with end-linked glycans. And so if glycosylation is successful, the protein should show a molecular shift. If glycosylation is blocked, no shift should occur. We can also do qPCR or Western for unfolded protein response, but no, I think the endo-H or just checking of the markers would help. How do proteins move through the GOLGI? Through the GOLGI. Goes from ER. Okay, mini review. Where's my eraser? Eraser. Here. It goes from this one. Proteins moving through the GOLGI. Move through GOLGI, right? This one, you start from the ER to the GOLGI, which has, let's say, 5. 1, 2, 3, 4, 5. This was the cis and the cis GOLGI network. Just the cis cisternae, medial cisternae, trans cisternae, and then trans GOLGI network. It goes through that. Okay, how do we check? If we find out whether GOLGI's surname mature and moves forward, then I would like to look for evidence that for individuals history change over time. Oh, that was the marker thingies where and track them over time to check if it's cisternal versus vesicular. If it's cisternal, wait, which one's the fixed? Vesicular is the fixed. Cisternal is the maturation one. So in the markers, if you see that these are the same, that the markers are the same, it would be fixed. But if the markers disappeared over time or appeared over time, then that means it was the maturation one. All right. I think, you know what? For GOLGI Apparatus, we actually finished it. I thought we wouldn't be able to finish it. My gosh. Alright. So, here's the thing. For the GOLGI Apparatus, we finished that. We can... Where's the next one? The next one is actually... Yeah. Oh, I didn't know that we'd finish the GOLGI. The next one is actually cell signaling. We can do it. Whoop whoop. Oh, that's so nice. Thank you for using the emotes. Like the GOLGI with the lesson yesterday and today was like, but I'm happy that we got through that one and it's gonna simmer. So here's the debate. I could try to eat breakfast, lunch, or dinner, not revealing the time zone. Or just pandesal. Or I could go through the cell signaling. I will go through the cell signaling. Why not? You know? Yes, you're welcome. And I'm gonna proceed and do some cell signaling first because I have it open right now. Yeah, the sensei. I What do you mean or? Of course, the or is go through the science. Yeah, cell signaling. I think I want to try and get through this though. Yeah, we're all here. We're gathered here today to do science because why not? It's a fun one. So intro to cell signaling. Let's see. Okay, I'll just drink water first. Because I have some pretty pictures for cell signaling. I like it. Hi. We're here. Okay. Let's go. The hair flip. Oh my gosh, will it track it? It doesn't. It doesn't track it. I love how the cells communicate. Yes, it's like cells at work where they talk to each other with their cell phones and they fight over iPhone or Samsung or Xiaomi or LG or a Google Pixel. Anyway, welcome to intro to cell signaling, where cells communicate over various distances, okay? Because it depends if they're near or far. So we're gonna talk about 4. We have contact dependent. Oh, let's see. I have a different picture for this. I'm gonna find it. I drew it on a whiteboard before, so I want to use that one as a basis. Where is it? Okay. Now, we have this one is different. There's paracrine, autocrine, juxtacrine, endocrine, and synaptic, okay? So I have 2 different versions of this. But anyway, I'll just draw this. I'll follow the other one. The one that it's more recent in my head. Paracrine. Nope. Immediately botched the spelling. We have paracrine. And paracrine, what is it? This is very local. So you have this cell that emits your thing, right? Your signal, the cell signal, the signal that you want to send. Me when science. What is that? what's that emote? The question mark emote. That looks fancy. The one who acts nearby. Yes, it would send this off, and then you have the receptor that receives it. But some cells don't have the receptor, so they're not the target cell. Then they get eliminated. Wrong elimination. Sorry. This one is eliminated. This one is accepted. They receive these. Good. So that's paracrine. Then what's the next one? Autocrine. Yes, autocrine. What is autocrine? So this cell sends out the signal. I'm gonna make the signal red. No, blue. Why? Because I like blue. I don't know if it's obvious that blue might be my favorite color, especially with the blue eyes, the blue glasses, the blue coat, the blue sword, the blue chat, the blue logo, the blue, literally the blue background. Whoops, wrong one. The blue background and castle. I think hopefully that's it has relayed the info that blue is OP. So yes, good job, Greg. They signal themselves. They send this out, and then the receptor, the receiver, is actually them too. So guess what? The cycle just goes on. So the best example for this would be tumor cells, cancer, because it's autonomy on cell proliferation. They can just go times 2 times 2 times 2 times 2. Okay? What's the next one? Juxtacrine. What's juxtacrine? That is the contact one, okay? So your signal is attached to your cell, and so to be able to do the thing, this one, the receptor should interact with that one. So this is the contact dependent. Yes, perfect. An example for that would be the notch receptor, like the delta ligand and angiogenesis. And then, what if your brain wants to talk to your liver? How's that possible? Well, that is where endocrine comes in. Or let's say the brain and the heart. That's where endocrine happens, because the cells here would release a signal. I'm gonna make it blue again because of reasons. Okay? Blue. It would, and then guess what? Let's say the wrong color. Yes, it's very long distance. And where does it travel? Imagine if it does text your liver. Oh my gosh. The brain and heart needs to grow. Yeah, they would just shout using walkie-talkie. But the walkie-talkie flows, the signal of the walkie-talkie flows through your blood vessels, and then that's how it reaches the other cells. Okay? That's how they receive the signal. Yeah, they travel through your blood. The blood. This is the blood. The circulatory system. And for example, would be insulin from the pancreas to your muscle cells and all that. And there's a bonus that I want to bring up. It would be, what's the fifth one? A special type. It's the synaptic. Okay? The synaptic one would be, you have this is the axon, aka the presynaptic ones, synaptic end. And then you have the dendrite, the postsynaptic end. That's why endocrine system exits in biology books. Lamau. Yeah. Oh, and this is the dendrites. And then you send the neurotransmitters here. The neurotransmitters will go and, like, let's say, attach to this, which causes some gates to open, which would lead to some stuff coming in or out. That's how it works. So that's cell signaling. But as for the type, I've been talking about receptors. When did I talk about them? Receptor, the receptor over here, and then there's also a receptor here, and there's a receptor here. So I brought it up numerous times. Regarding the receptors, there's like 2 types, I think. And that would be What? Here. Receptors. Receptors. The types of receptors are cell surface, and intracellular receptors. Okay? Guess what? Where are they? One is on the cell surface. One of them is inside the cell, intracellular. So, cell surface detects the signals outside the cell, and that triggers the pathway. It's very embedded in the plasma membrane. Plasma membrane looks like this. Fancy little guys. This is a receptor. It's on there. And an example is the GPCR, the G protein coupled receptor, and the RTK, receptor tyrosine kinases. And I would like to draw them, because why not? Oh. Medyo. Okay. Here. Oh, a different page had 3. Oh, that's a specific type. This one's just general type. Okay. Cell surface. We have an example is GPCR or RTK, where you have this cell, you have the cell surface, and then you have the hydrophilic signaling molecule. That's the target cell. Meanwhile, intracellular is detects signal across the membrane and directly influences the gene expression. So it's inside the cell. You bind the small signal molecule. Oh, it binds small signal molecule that diffuse across the plasma membrane. So you go through them. Ooh, what's that emote? A wolf emote? I need to have an emote that's a question mark, but it might be... Oh, the closest I have to a question mark emote is this one. It's the very confused one. So yeah, you have the intracellular receptors. You have the carrier protein. Oh, they go through. Your thing goes through, and then it passes through the nucleus as well. Carrier protein. So once inside, the signal molecule binds to the intracellular receptor protein that regulates the gene expression. Just go through there to the nucleus, and that's your gene expression, the DNA. So yeah, one is on the surface, one is outside. All right, what's the next one? Okay, here is the thing. I am hungry. I think I need to eat. Okay, I'm gonna eat first. Yes, but I will continue the cell signaling lesson later or at some point in a bit. Anyway, a waiting room will be displayed. But yes, thank you very much for I was like, I can hear the stomach. I was like, I might need to eat. But yes, thank you very much for joining me today in this extremely long science stream. I can't believe I yapped about the GOLGI apparatus for more than 2 hours. Yeah, that's why it's like But I learned a lot. Hopefully I was able to relay as well some of the lessons. But yeah, see ya in the next one. Bye bye.